Welcome. Let's take a look at another raffle. So a charity is running a raffle where 2,000 tickets are sold at $2 each. They will give away 2 prizes valued at $100 each, 2 prizes valued at $50 each, and 6 prizes valued at $10 each. What is the expected value if you buy 1 ticket? All right, so let's keep track of first some total winning tickets. I'm just going to circle up here 2 winners for 100, 2 prizes at $50 each, and then 6 prizes at $10 each. So 2 plus 2 plus 6 would be 10 winning tickets. And if they sold then 2,000 total tickets, 2,000 minus 10 would leave 1,990 losing tickets. All right, so if you wanted to just make a note here, so I just did 2 plus 2 plus 6 to get 10 winners, and 2,000 minus 10, the complement there would be the losing tickets. Okay, so let's go to our table and do net gain. So X, our random variable, is net gain. So if you win $100, they're going to give you a $100 prize, but you do have to subtract the cost of your ticket. So you paid $2 for a ticket, so you will net $98. If you win $50 minus the cost of your ticket, your net gain will be $48. And then $10 prize, you'll net $8. And then if you have a losing ticket, you will gain nothing from that ticket, but you did pay for the ticket. So you're going to be down $2. All right, and then let's go to probabilities. So your chances of getting a $100 prize, 2 out of those 2,000 tickets. And I'm not going to reduce fractions here because I'd like to work with a common denominator later. So I'll leave that 2,000 as our denominator. And then $50 prizes, there were 2 out of the 2,000 tickets. $10 prizes, there were 6 of them, 6 out of the 2,000. And then your chance of getting a losing ticket, 1,990 out of 2,000. All right, so if you add up all those probabilities, you will get 1. So we'll be sure that we did that correctly. So if you add up all of the numerators, that will come out to be 2,000. All right, so let's calculate your expected value. So if you were to play this raffle over and over and over again, on average, what is a ticket worth? So it's called the long run average, and it's the sum of each X times its corresponding probability. All right, so there's our formula. And I'm going to put the pairs in parentheses here. So the way we're going to think about this is if you played this raffle and just decided to buy all the tickets, so you spent your money and bought all 2,000 tickets, this is what would happen. You would make $98, and that would be on 2 tickets out of the 2,000. Plus, you would make $48. That would happen on 2 of your tickets if you bought all of them. Plus, you would make $8. That would happen on 6 of your 2,000 tickets. Plus, now you're actually going to be out $2, and that would happen on 1,990 of your 2,000 tickets. Okay, so by leaving that common denominator, we could add those fractions. And I'm just going to do all the numerators now, and I'll show you that on the calculator. I'm going to enter it on the calculator exactly as it's written. So I'm going to do parentheses. So numerators, 98 times 2 plus 48 times 2 plus 8 times 6 plus, and then remember to negate a number, you use your negation button next to your enter button. So I'm going to negate the 2. So -2 times 1,990, close parentheses. All right, so that numerator will be how much money I gain or lose if I bought all 2,000 tickets. All right, and that comes out to be negative, so I'm going to be losing money. So minus $3,640. So that numerator tells me what happens if I bought all the tickets. And if we want to know how much that is per ticket, that's why we divide by 2,000. So if I bought all the tickets, each one is worth $1.82, but it's negative. So negative 1.82. All right. So you can also think of it as if you played the lottery or the raffle here just once, you might end up actually winning the prize. So this number isn't what happens on any individual play. It represents on average, if you were to play this raffle over and over again. So this is why it says if you bought tickets repeatedly in the long run, you would end up sometimes winning, more often losing. On average, you are going to be losing since the expected value is negative, and you'll be losing on average $1.82 per ticket. So since we said lose, we don't write negative in the sentence, but the expected value itself is a negative value. All right, so what if we did buy all 2,000 tickets? So two ways to get this answer. One is just from what we wrote here. I know that I'm going to lose a total of $3,640 if I bought all the tickets. And then the other way to get that answer is if we know we lose $1.82, but this is per ticket, then if I multiply that by all the tickets, 2,000, that will also give us the 3,640. All right, so this number is per ticket, and then multiplying it by all the tickets is another way to get that total loss. Okay, just going to do one more spinner question here. Not one more. Our first spinner question, that one was a raffle. So we've done a raffle there. Let's look at a spinner question here. So number 4. All right, suppose we play a game where it costs $10 for a spin of a spinner. The spinner has 5 equally likely regions, and we're going to win $20 if we land on region 5. I'm just going to actually put that on the picture over here. So if I land on region 5, that would be a $20 gift card. And then regions 3 and 4, those would each be a $15 gift card. And then on regions 1 and 2, we don't win anything. Okay, so this is kind of a reminder that expected value is basically a weighted mean where the weights are the probabilities. So let's step through this. All right, let's go with money first. If you win a $20 gift card, so you'll be getting a $20 gift card, but you did pay $10 to spin the spinner. So minus the $10 to play the game, you will be up $10. If you win a $15 gift card and it costs $10 to spin, you'll be up $5. If you don't win anything, then you did pay $10 to spin, so you're going to be out $10. All right, so probabilities, there's 5 regions on the spinner. So the $20 region, there's just one region out of the 5. And then $15, there are 2 regions out of the 5. And then finally, winning nothing also happens on 2 regions. All right, you can always check again, add your probabilities, make sure you get 1. So the numerators, 1 plus 2 plus 2 are 5, and 5 over 5 is 1. So we're good there. All right, so let's see what happens if we play this game over and over and over again. So on average, so calculate the expected value. In the long run, what would I expect per spin of the spinner? So I will just remind you here that this is the mean of the random variable. So the long run average. All right, so the formula is x times p of x. And I'll put these in parentheses again. So we can think of it as, in theory, if we spun the wheel 5 times, this is what would happen. I would make $10. That would happen on 1 out of 5 spins, plus the next X, $5, and that would happen on 2 out of the 5 spins in theory, plus, and now -10, and that would happen with a probability of 2, so on 2 out of 5 spins. Okay, so by leaving that 5 there, we've got our common denominator. And now I'm just going to write down these individual numerators. So 10 times 1, that would be, I'm going to put the units there, that would be $10. That would happen once, plus 5 times 2 would be $10. And then -10 times 2, now I'll just write minus. So -10 times 2 is -20. So plus a -20 is subtracting $20. All right, so what happens here is that 10 plus 10 minus 20 is 0, and 0 divided by 5 is 0. So here's the deal with this game. So if you just play once, you might win $20. You might win 15, you might win nothing. Who knows what's going to happen on one individual spin? That's why it's called a random experiment. But now what I can tell you is if you did play this game a large number of times, in the end, your winnings and your losings are going to actually balance out, and you will basically net nothing. So you won't come out ahead or behind, and we often just call that breaking even. So you can expect to break even. All right, there you go. So that's a spinner example.